Hey there, fellow data and analytics aficionados, and thank you for joining me today in our episode of Caserta's Data Intelligence webinar series. I am your host, Remy Rosenbaum, and you guys probably know that it's no secret that data is a goldmine of business insights, but many organizations are missing out on all these gold nuggets that will help deliver the crucial competitive advantage over the competition. So today we're going to delve deep into how we can find these gold veins and mountains of data and extract those high value insights that we all crave. So to better understand how to do so, I've brought on Robert Dempsey, who is going to tell us all about the key considerations and challenges of operationalizing machine learning at scale. Robert has, for the past 22 years, built, led, and developed multidisciplinary teams for clients, employers, and himself, while developing hands-on experience with a wide range of technologies. He's consulted to Fortune 5 and 500 companies, spoken nationally and internationally on software development, authored a tech book, held a two-day conference, and built 3 businesses in IT services, web development, and online marketing. So you have a very impressive presenter for today. A bit of housekeeping, and then we will get started. Caserta, if you don't already know, is a professional services firm. We are laser focused on data and analytics engagements. We deliver strategic assessments with actionable roadmaps, craft innovative designs and architectures, and perform advanced implementations that leverage the latest technologies and proven frameworks and methodologies. All of our teams are led by data scientists and data engineers who share a relentless dedication for solving our clients' data analytics challenges fast. Our complimentary webinars are designed to really give you insight into today's hottest technological trends and issues. And after today's presentation, I encourage you to speak with us about any questions on how to apply what Robert is going to share with you at your organization. Our initial conversations are always free. And if we do find an opportunity to work together, that's wonderful. But if not, we will happily point you in the right direction. After the webinar, I will personally send you a recording to the email address that you registered with. And if you have any questions throughout the entire presentation, please enter them in the questions panel, and we will answer them during the live Q&A session at the end of the webinar. Robert, the stage is all yours.
Yeah, thank you, Remy. Wow, quite an introduction there. So welcome everyone to how to operationalize machine learning to extract high value business insights. Quite a mouthful, and I got a lot to share with you today. So first off, I just want to say that there are many reasons to operationalize machine learning, and I've listed 30 here across marketing, finance and operations, as well as product. So some of the things that you can see here under marketing include real-time promotions, forecasting, addressing churn. On the finance and operations side, fraud detection is huge in the machine learning space. We all may have run into a failed credit card transaction at one time because some system thought it was fraud, right? Predictive maintenance, cybersecurity, things of this nature. And then finally, on the product side, things including personalizing user experiences, getting more accurate search results. So there are a vast amount of use cases where machine learning can really come into play, and that's why we want to deploy it inside of our organizations. So first, though, what we need to do is talk about marshmallows. So in 1972, Stanford conducted a famous experiment that became known as the Marshmallow Test. And what this was, they got a bunch of children and they offered them one small but immediate reward, which is a marshmallow. Or if they waited for a period of time, they got 2 marshmallows. Now, first off, let me state that I am not calling anyone on this webinar a child, far from it. Now, my point with the marshmallow, to try and lighten up the mood as well, is that there is some foundational work that you must do in order to fully take advantage of machine learning. Now, where does that delayed gratification come into play, though, you might wonder? Well, as a systems engineer by training, my inclination is to start building systems. Now, you might work with engineers rather that work on that type of basis. They just rush forward as soon as they get a requirement or someone has an intriguing idea. For instance, in a previous client of ours, there was one engineer who literally just kind of went off like on his own. He had an idea and built it out and ultimately couldn't even get it into production because he was that kind of an engineer. He just wanted to plow forward without putting in the foundational work. Now, Over time, right, engineers learn to plan up front, as we all do, but not so much that it gets in the way of progress. However, we absolutely need to put in these foundations so that we can move farther, faster. And I can tell you from experience that if you can delay the gratification of just starting to build, to rush into trying to get a machine learning model out there and put your foundation in place, that you'll get way more than just 2 marshmallows. You'll have an entire bowl of marshmallows. Now, maybe you don't like marshmallows, but the analogy still stands. Now, this may seem like a lot, all those use cases that I showed for how you can operationalize or what you might operationalize machine learning for. And maybe when it comes to machine learning, perhaps you feel a bit lost in the woods, right? Maybe you've read some white papers about it or attended other webinars, and you can see a little bit of light, but you still feel kind of mostly in the dark as to how to actually get it working inside of your organization. So by the end of this webinar, you'll have a path to operationalizing and scaling machine learning, which will help you get through these dark woods. And again, there are so many reasons that you might want to do it and more. Now, let me define though what I mean by at scale, because that's kind of a loaded, not kind of, it really is just like a loaded term. So first off, at scale means that you will be able to do more concurrent data science projects. You can iterate faster through these projects. You can perform more experiments, which is huge in the machine learning space to be able to do. A/B testing, things of this nature. And also you get increased speed to insight, which can give you an enormous competitive advantage. Now, to do any of this though, you must have data. Machine learning is driven off of data. It's crucial. Now, we've worked with a number of clients who are 80% of the way there. However, sometimes they did need to make updates to their products and systems to capture the data that they needed in the first place to produce the insights that they wanted to get out of their products, whether those are customer-facing products or purely internal. So I just want you to keep that in mind moving forward. Now, as Remy mentioned, here at Caserta, we are a data analytics consulting and implementation firm. He said it even better than I can, so I'll just stick with that. Also, though, do want to say that we're helping leaders just like you do amazing things with data. Companies including the New York Times and Domino's, Equinox, Citibank, Liberty Mutual, folks like that. So with that said, let's get into it. First off, I want to share with you 4 foundations that you really need to build upon. The first is collaboration. And what I mean by this is creating a cross-functional team of product owners, data scientists, and data engineers. You need everyone at the table. Business says what and why it needs to be done. Data scientists can tell you how machine learning can actually help you to achieve those business goals. And then data engineers have the infrastructure and get the data from A to Z to get everything in place for use by those models. So foundation 1 is absolutely a cross-functional team. If you don't have business at the table, that's going to be a problem. If you don't have data science or data engineering at the table, that's going to be a serious challenge. You really need to get everyone together. Foundation 2 are creating your guiding principles. So we have found that with any project, whether we're talking data strategy, data architecture, whatever it may be, coming up with a set of guiding principles in the first place just helps enormously to get everyone on the same page. And what I mean by guiding principles is this. You start with a vision statement, and then you define the principles from which all of your decisions are then going to be made. So some examples that we've used on data architecture projects include, we want to be cloud first. A lot of clients of ours have on-prem, they want to move to the cloud. How do we enable that? But they want everything new and moving forward to be cloud first. Doesn't mean cloud only, just means cloud first. Stream first, so moving from batch systems to real time. Data availability key, right? Making data available in various fashions. Data quality, an absolute must, a foundational guiding principle, and also flexible architectures. So these are just a few of the many guiding principles that you want to lay out in the very beginning of any data project. third foundation is data governance. Now, there's a lot of definitions, so I wanted to share this one with you, which is data governance is a framework and approach for assigning rights, responsibilities, and authorities to ensure that an enterprise, its regulators, its shareholders receive reliable, authentic, accurate, and timely information. Now, data governance is something that, in my experience, a lot of companies don't have. I've worked with some really big clients, worked in some real big companies, and data governance was almost an afterthought, but we want to make it first and foremost. That's why it's a foundational, it's a foundation. So organizations with data governance programs also are much more effective at actually deriving value from their data, because they know things like what's the quality, how is it going to be accessed, what kind of security measures do we have in place, et cetera. They're more data literate, they're more data driven, which is very important in this day and age, and they're often capable of being much more agile and adaptive to changing business environments. So while the term data governance itself might sound bureaucratic, it absolutely does not have to be bureaucratic, and in fact can make you more agile and adaptive. Now, the fourth foundation is ownership, and this is defining who owns what, and this is key, especially with larger organizations. Now, things that you want to talk about are with the data governance council defining data standards. They own those data standards. You might say that source teams own their data and are responsible for making it available. So that might be a product team that is producing data. So they're responsible for that data. They own it and they have to make it available for use and consumption into a data platform. And then you might also then say that the data team owns the actual data platform and is responsible for making that enterprise data available. Now, I can tell you from experience that having ownership well-defined, especially if you say that source team has owned their data and the data team is there to enable them to share that data with the greater enterprise, can garner a huge amount of trust from your teams and allow all of your data projects to move forward that much easier. Now, one of the things too that I really just have to say here is that DevOps is a huge key to success. So with one client where we were on a year-long project to build a data platform, going from a large batch system to a real-time streaming system, ultimately the team that was actually developing the platform had to manage all of the infrastructure as well. And that ultimately took up, well, in the very beginning, it took up literally months of their time because they were fully responsible for creating and then maintaining all of the infrastructure, right? So those months were months that they were not actually developing ETL processes and data cleansing procedures and things of this nature, data quality checks that they could have been putting into place. So having a DevOps team, which is developer operations, having people that are responsible for maintaining and building the infrastructure in the first place, putting it up, working with the data team is huge. So the choice really is, do you want the data team to be building and maintaining the infrastructure, or do you want them providing the real value, getting you your insights a lot faster? I would say probably the latter. However, sometimes it's also a journey, which is completely understandable. Now, in order to operationalize machine learning, again, once we have that solid foundation, I want to share with you an architecture of what this actually looks like in production. So the architecture that you see here, it might be familiar to you as a Lambda architecture. And the reason that I'm showing this is because a lot of clients that we've worked with over time have a lot of batch data sources. Batch sources, at least from what I've seen, are not going away anytime soon. It's just the nature of the beast. Sometimes you have data that isn't available in a real-time fashion. Happens a lot. So for a modern data platform, definitely recommend having a system that supports both batch and streaming. Now, while a completely fully modern architecture may be stream only, again, the reality is that companies aren't really ready for it. So supporting both over time allows you to evolve the platform and evolve with the rest of the technology ecosystem as your company moves to much more of a real-time posture. Now, one of the things that I do want to share with you is a quick story about getting to an architecture like this. So again, working with a large client, and what they want to do is move a 500 node Spark cluster to the cloud. So ultimately they did a lift and shift, which I don't recommend, but that can happen. But they did a lift and shift. They took their 500 node Spark cluster that was on-prem, put it in the cloud. It cost a huge amount of money to do that. But ultimately, once they implemented an architecture like this, they cut their savings down from literally hundreds of thousands of dollars per month to tens of thousands of dollars per month, which was an enormous cost savings. Like basically it was an order of magnitude, going with, again, real-time streaming data sources, using Kubernetes specifically, and not having to need a 500 node Spark cluster up and going, which on-prem can be expensive, but also in the cloud, it can be quite expensive to do things like this. So an architecture such as this that I'm sharing with you today can save you enormous amounts of money compared to what an on-prem solution might look like if you deploy it into the cloud. Now, looking at each part of this, I want to start off by talking about data ingestion. Now, spoke a bit about this again, but a modern data platform is going to support both streaming and batch, with stream being primary, again, helping you to move into the future. Now, that batch data could come in hourly, it could come in daily, monthly, whatever it needs. But again, you really want to take a stream first posture as much as possible. So the next part is looking at the data processing and storage. So there's a lot here in each of these little boxes. So just want to get into a little bit of the nitty gritty with you. So first off, when we are ingesting data, it's going to come in. If it's a stream, it's going to come into that stream processing box right there and immediately be stored into raw storage. Now, if we're doing batch ingestion, though, that is also going into raw storage. And the reason that I call that out here is because, as I said in the beginning of the webinar, machine learning requires a lot of data. And you might have data, especially in large organizations, literally all over the place. Could be in SQL databases, files, key value stores, like HDFS, who knows? It could be all over the place. If you have data all over the place, it makes it that much more difficult for your data scientists to start doing data discovery, feature engineering. So it reduces, that increases the amount of time that it takes to do that initial discovery phase. So we want to cut that down. And the way that we cut that down is by saving all of that data into raw storage. Now, you might be thinking, well, am I not duplicating data? And yes, in a way you are. However, by centralizing it, the cost savings that you can get on your projects well outweigh the cost of storing all of that data raw. And especially with different storage solutions available, the cost, especially in the cloud, is very minimal. So you want to store everything raw. Next, we have, after the streaming process, to the right of that, we see enrichment and curation. And this is where you start combining data sources and things of this nature. It could be one part, it could be many processors. And then you store all of that in a variety of methods. So while the process storage, you see here, I've used 3 different icons to represent that. That could be because maybe you need something in low latency data storage for certain use cases. Maybe you can deal with file-based storage, object storage, which might take a bit longer to query, but maybe that's okay. So you really want to base your process storage on the use case. And then finally, you have aggregations. And aggregations are merely those things that you might suspect are, hey, we need to run some calculations once a day. We have to wait for all the data to get in. Once it's in, we can run an aggregation, and then we store that into aggregation storage. Awesome. Now, in the top part of this diagram, the last part I want to call out here, we see machine learning and we see models non-machine learning. So a lot of organizations too, as they start to move to using more data science techniques, more machine learning models, are using rule-based systems. Well, that is I'm not here to say, hey, just throw those out. In fact, sometimes those rule-based systems work great, or if you've been using them for a while, they actually have created the data sets for you that will then be used to train the machine learning models. So great stuff. Definitely don't want to get rid of any of that. So just because we're using more machine learning doesn't mean that those models necessarily, or those rule-based systems, completely go away. We might need to access both of those. So that's why here in this part of the diagram, I have both of those here for you. Now, this is a bit more of the detail on, again, how that processing works. Again, everything gets stored in a raw storage, right? A message queue is forming the backbone. So pretty standard stuff in streaming systems. Use a message queue, might be Kafka, might be something else, but either way. You then have a series of data processors, which could work in real time on data in that message queue, or it could be talking with the raw storage and running in batch. So either way, you do want to be able to support processes at that level that are able to operate on the streaming data, but then can also handle the batch processes. Because again, sometimes you just have data that only arrives at certain times. Definitely seen this in retail use cases where they have servers inside of the stores, and then they are basically uploading data to whatever system, maybe every 5, 10, 15, 20 minutes, whatever, right? And it's just a limitation. So you want to be able to then get that into raw storage and process it as soon as you can, but it's not coming in as a stream, it's coming in as a batch. And then finally, on the right-hand side, I have the integration layer, which could be a series of methods for customers, whether that's literally a customer, like in a retail store or whatnot, or another team, how they can access the data that's inside of this data platform. A lot of the common ones that we've seen are APIs, streams, direct query through one way, shape, or form, file-based push, and also a semantic layer. All of these are very common access patterns that get you to that data. Now, secure zone is another important concept to have inside of your data platform, mainly if you're dealing with compliance. So we've definitely had customers that are dealing with compliance, need to put data into a secure zone that's completely separate. This could include PII data, things of this nature. Data that needs to be kept completely physically separate from the rest of the data platform. However, I do want to note here that we're still using the same ingestion method in the beginning, the same stream and batch ingestion methods to get that data into the secure zone. Basically, we just route it, say, effectively, is this data secure or does it need to be secure? No, okay, great, go path A. If yes, then all right, go path B. But the processing ultimately works in exactly the same way. So you don't need to reinvent the wheel or anything else like that for processing secure data. You just need to make sure that that infrastructure is kept completely separate. Very important, especially if you're dealing with compliance, regulatory, things of that nature. And again, the integration layer, as I had mentioned, there's a number of different ways for you to integrate with the business and with other applications that need access to the data that's within the data platform. And some of those could also be another machine learning system that uses features that are actually generated and stored on the data platform itself. Now, the machine learning sandbox is another very important, like just crucial concept in my opinion, of operationalizing machine learning. And this sandbox is something that sits between the systems of record, which are those databases where all the data originates into, and the data stored in the data platform. It's almost like a middleman, if you will. Now, a machine learning sandbox will hold its own compute, and it's also an asset of the data science team. And what this does is it enables them to more rapidly test and train and iterate through models. They have access to source data if they need it for some reason because it's not in the data platform, but then they have access to everything also that's inside of the data platform itself. But again, this is usually its own infrastructure, maybe Databricks, notebooks, GPU machines, right? Whatever the data scientists need in order to train and test out various models. And again, this helps them to be very agile and just iterate all that much faster. So a crucial part of the infrastructure. Now, much like we have all of the foundations that we discussed in the beginning of the webinar, the entire data platform sits on top of 4 underpinnings. And each of these is a huge topic, which you'll hear about, I'm sure, in upcoming webinars. But I just want to give you an overview of each of these right now. So the first is a data catalog and metadata service. And what this does is it allows anyone that might be interested in getting data from the data platform and running a query to understand what exactly do we have here? What are the assets, the data assets of the organization? It's typically a platform that's self-service. They can go in and see what tables there exist, or what data sets with what fields, and then they can get ideas of, hey, how might I use this? This is also an enormously important concept for excuse me, data scientists as well, so that they can rapidly find out more about the data without having to engage the data team themselves, which can take away oodles of time basically from them. So we give them back their time. We create data catalog and metadata service. The next is job scheduling and orchestration. Things that you might think of here are things like Apache Airflow that basically allow us to run batch jobs and orchestrate entire workflows. Could be an Airflow, could be a completely managed service. Definitely a foundation that runs across the entire architecture. Next is logging and monitoring. And this is huge. My default stance is log absolutely everything. Find an inexpensive way to get those log files, store them for as long as you possibly can, because it comes into play with the monitoring. And what I mean by monitoring rather is being able to know the health of the platform and how well it is performing. If your organization has very strict SLAs, or the data team is attempting to achieve an SLA, this is where the logs will tell you whether or not we're meeting those. And also, you want to have, as much as possible, real-time monitoring in place in order to know as quickly as you can if anything is happening with the platform. So crucial, logging and monitoring, foundational. And then finally, data security services. What this does is it tells us basically who is able to access what. Again, very important, especially if you're in regulated environments where you need to also provide audit logs of who is actually accessing what data and when. Huge. So those are the 4 underpinnings. Now, I want to share with you some example cloud architectures as well. So this might be a little bit easier to see in the recording. However, this is an example of things that you can use, managed services that you can use on Amazon Web Services. Starting from left to right, we have things including AWS ML, the machine learning offering for the machine learning sandbox, Kinesis and Snowball for ingestion. There's a variety of processing and storage options, but mainly you can see here that for every part of your data platform, Amazon Web Services absolutely has an offering for it. And so does Azure, and so does Google Cloud Platform, or GCP. This example is the various options for each part of your modern data platform that you can use from Azure. So things including Azure ML for the machine learning sandbox, Event Hub and Data Factory for both stream and batch ingestion. And again, a variety of data processing and storage options for raw, processed, and aggregate data. And ultimately also machine learning applications and your reporting and analytics applications. So key takeaways that I want to say here are, again, the keys to operationalizing machine learning at scale are effectively planning and execution. Probably not too surprising for you. So what you want to do is first assess. You want to understand where you are today and where you want to be, and then what you need to get there. Forming a gap analysis, if you will, to understand what those 2 states are. We do a lot of this work with our clients. Next is you want to determine which tech stack to use, especially if you're looking at cloud providers. Do you want to use AWS? Do you want to use Azure? Do you want to use Google Cloud Platform? Which of these is best for your organization based on your needs? You need to decide that as well. Foundation, again, before building the data platform, you want to put those 4 foundations into place. And then finally, you build it. And I love this term. I heard it, one of our clients said it. So unfortunately, I can't claim credit for it, but give credit where credit's due. What he said is minimum viable platform. So what that means is you build a little bit of each part, the ingestion, the data processing, the data storage, and the access, that integration layer. And you go from there. So you start building out on use cases. What do we need? But you build that minimum viable platform so that none of it's throwaway. You can just start building on top of that. So that is, those are the key takeaways here. So one last plug for us too. You can, as Remy said in the beginning, you can definitely contact us today for a free machine learning readiness assessment or any other way in which we can help you. So that brings us to our Q&A, and I'm happy to answer any questions that you all may have today.
Robert, thank you so much. That was excellent. First of all, I love the bit about minimum viable platform from the lean startup methodology, of course. That was wonderful. Now I encourage everyone, if you have any questions, please ask them in the questions panel and we will get to them. Robert, so the first question is more about ownership. Who in an organization is the most natural person to own a project like this? Would it come from the business or would it come from, would it come from the tech side of things?
Sure, yeah, that's a great question. So typically what we've seen is the ultimate ownership of the platform falls under technology, but with anything, technology does not happen in a vacuum. So really all of the requirements of the data platform, all of those use cases come from the business side. And that's ultimately what is driving as well the measurement of the platform itself. So again, are we meeting SLAs of the products, right? Are we delivering the value that we want to do? So ownership, data team, requirements, business.
All right, great. And this is a question about regulated industries. Let's say in financial services, are there any problems to run up against regulation while using sensitive data for a machine learning project?
Yes, absolutely. So I think the biggest concern that you might have in the financial industry with machine learning is, firstly, being able to explain what your models are doing and how they're getting the results that they are. So I've worked with folks that are in banking that had to sit down with the regulators and literally show step by step. Here is the data that we have. Here's how we train the models. Here's how it's producing its prediction, etc. So that absolutely is part of it. Using sensitive data also can potentially form bias. So if you get enough information on someone, right, like or you're deriving. So let's say we take, I don't know, like the average cost of housing in a person's zip code, and we're going to use that to decide, are we going to lend this person some money, right? Like even standard things like that could actually become worrisome for regulators because it could be seen as bias. And so those are two biggies that I've seen in the financial industry that you really need to be concerned with.
All right, great. That's all the time we have for today. Again, Robert, thank you so much. That was an excellent presentation. And I will send the recording out to all of you afterwards. Robert, thanks so much.
Yep. Thank you, Remy. And thank you, everyone.